All right, so today's lesson is on domain and range and deciding if a data set, a set of ordered pairs, a graph, a table is called a function. So domain and range might be new to you. You may have heard the word range when you're talking about mean, median, mode, and range. We are going to, it's kind of a similar concept, but we've got domain and range, and they stand for something. So let's start with the ordered pair. What is an ordered pair? Well, an ordered pair consists of two coordinates, an x coordinate and a y coordinate. That's an ordered pair. And you should be pretty familiar with plotting points. Like if you had to take 2, 5 and you plot the point, or 3, 7, or 2, -5, or whatever, and you plot the points. Those are ordered pairs, okay? The domain is referring to all the x values in the set of numbers that you have, and the range refers to all of the y values in the set of numbers that you have, okay? And this is going to build. This lesson is going to start out very, very easy, like the process of what we're doing when we list the domain and we list the range is very simple here in the beginning, and then it progressively gets more intense. So make sure you pay attention. I would also advise you that anything I say in the lesson that maybe I don't write on the lesson PowerPoint here, that you still put it in your notes. So anything extra, remember that I give you is just a template. You don't have to, if it doesn't have a blank, doesn't mean you can't add more into it. Okay, write all over there because you're going to need to come back and you're going to need to process. And let me also say this, because we just got done doing arithmetic sequences, where basically if you understood how to plug in numbers and yada, 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 you were okay, right? Well, this is a little different. There's not going to be work involved here. It's all mental and analyzing numbers and graphs and then writing the answer down. There isn't a process of adding or subtracting or multiplying or dividing like that. Okay, so pay attention. Yes?
Yes.
Yes, I thought maybe you need something. I know we need these shut too. Okay. We might have some visitors come through because there are visitors here today. But of course, we will just continue on as normal. Okay, so it says find the domain and range. So we just said the domain is all the x values, or all the x values. So do me a favor. Let's go through and let's circle all of the x values right here. Okay, so all of the x values. So the x values are 4, 6, 4, 5, and 5. Now, when we are listing the domain, all the x values, I want you to write them in order from least to greatest and without repeating. So that would be something you would write out to the side, like Isaiah is doing right now. Miss Wilson said, write them in order from least to greatest and without repeating.
What's without repeating?
I'm going to show you in just a minute. Write them in order from least to greatest without repeating. Anybody already have an idea what I mean when I say without repeating? Jackson?
Just write 4, 5, and 6.
Right, when you see this, you see how there's a 4 shown 2 times? 2 ordered pairs have a 4. We're not going to write it twice. Same thing with the 5s, right? So let's list our domain. Our domain in order from least to greatest would be 4, 5, and 6. And you need to put it in little brackets like that, the very best you can. Okay, those are the domain values. All right, the range values are the y values. Those are these values beside the x values. So we're going to do the same thing. What's the smallest one? 3, 6, 7, 19. Don't forget one. You forget one, and your range is wrong. You don't have all of the values. Okay, so that's pretty easy. That's pretty easy. All right, let's do another one of those. Okay, we have to label the domain for this set of numbers. It's a set of numbers. It's called a set of numbers. The little brackets refer to what's called set notation. The set of numbers. It's just mathematically something that we say. Okay, so let's put these in order. So, what's the smallest?
-3.
Next?
-2.
And?
0.
And?
4.
Good. Okay. Can we do the range now? Okay, what is the smallest?
5,
Okay,
7,
okay,
8,
uh-huh.
22.
Okay, very good. Super easy, right?
Yeah.
Okay, you're going to do 3 and 4 on your own. I'm going to do it up here without talking. When you're done, you can look up and make sure you have them correct. Or look up here and make sure I did it correct. How about that? Okay, any questions on those two?
Yeah.
Everybody's okay? Isaiah, are you okay?
Yeah, I'm just copying.
You're fine. I just want to make sure we're all good. Okay, so what have we learned so far? We have learned that the domain refers to the x values, the range refers to the y values, and that we can list our domain, we can list our range, and when we do, Ms. Wilson prefers that it's in order least to greatest and without repeating. Okay. All right, now, next is determining if a graph or a set of ordered pairs is a function or not. Okay, so I'm going to do a lot of talking. I want you to listen. I want you to feel free to write anything down you want. I'm going to try to use my little arrow tool for those of you watching the video, so maybe that will help. And we'll go from there. Okay, so in bold it says a function means, okay, so if you're like, well, what in the world is a function? A function, what that means or represents is whenever you have an input value, like a value for x, and you put it into a function or into an equation, out should come one answer, your y value. So for example, let's say we had something like f of x equals x plus 2. And let's say I plug in, let's say I want to figure out what f of 5 is. So I plug in 5 here. I'm just making this up. Well, f of 5 would be what? What's 5 plus 2? 7. Okay, so when I input this 5, out comes this 7. That is an ordered pair, 2, 7. When you input the 2, out comes the 7. When I input a 2, I'm not going to get anything but a 7. Correct? Okay. Now, there are some problems like absolute value equations that you did when you got multiple answers, but we're not going to deal with that for right now. Okay? So for right now, anytime you put in a value, out comes one number. And as long as that happens, it's called a function. If for some reason you see a list of ordered pairs, because that's what we're about to have, right? A list of ordered pairs. And you see right here, when I plug in a 2, out comes a 5. That's different from here. I picked 5 here, and out came 7, right? Okay, so when I plug in 2 here, out comes a 5. Great. When I come here, do I see any other 2s here that turn out to be a different number? No. When I plug in 3, you say plug into what? We don't have the function or the equation here. We just have a set of ordered pairs. Okay, you don't have to be able to do this. You just need to say, is 2 only going to a 5? Well, let me see. Do I have any more 2s? No. Is 3 only going to -5? Meaning when I plug in 3, out comes the -5. Well, let's see. Are there any more 3s? No. When I plug in 4, out comes a 5 and only a 5. Do I see any more 4s? No. And same thing for here. So really what you're looking at is you're looking at the x values, also known as the domain, and you're seeing if any of the x values are repeating. If you notice that they repeat, like let's say this is 2, 5, and then let's say this one is 2 again, but it's going to -5, that would be a, uh-oh, that's not a function, because that's not okay for that to happen, okay? So since everything checked out here, since 2 only has one y value, 3 is going to a value 4, and 5, we're good. So we're going to write, yes. What that means is, yes, this is a function. I don't like the directions. I want it to say, is each, scratch out the A, is each relation, scratch out the or, a function. Okay, every set of these numbers is a relation. It's relating things together. I want you to tell me yes or no. Is it a function or not? Okay, so it is a function because 2 is only going to 5, 3 is only going to -5, 4 is only going to 5, and 5 is only going to -5. It doesn't matter about these -5s right here. We're not looking at the range. We're looking at the domain. Look at the next one. 5 is going to 0. Great. Do you see any other issues along here? What do you see?
There's a 5 and a 1.
Yes. Do you see here? 5 is going to 0. But 5 is also going to 1, and that's not okay. The domain can't have 2 separate values. What you're saying is when you plug in 5, out comes a 0 and out comes a 1. No, that's not going to be a function. Okay, so we're going to write no.
Wait, so we're writing no, or are we writing relation and function?
That's why I changed the directions. All of these are relations. So the directions say, is each relation a function? Basically, are these functions or are they not functions? Sorry about the clarity there. So, number 7. Look at number 7. Why is it not a function? So 3 is going to -1 and 3 is going to 2. Yeah, that's not okay. What about number 8?
That's fine.
That's a function. -2 only goes to 9. 3 only goes to 9. -0.5 only goes to 9. 4. They all go to 9, but that's okay if they all go to the same number. You just can't have x values going to 2 different y values. Okay, so you're looking to see if the x values repeat. And if they do, see if they go to 2 different numbers. Now let me show you something real quick. Just a minute, Kate. Look at number 7. If you notice that you see 3 repeat again for the domain like this, but let's say this was 3 is going to -1, and let's say this one over here was 3 to -1, so basically it's the same point. That's okay. That is okay. That is okay. It's only if they go to 2 different numbers. Is that your question, Kate?
Yes.
Perfect. I'm a mind reader. Not really, but. Okay, so what did we decide on the last one? Yes?
Yes.
I think I hear people in the hallway. Okay. So, now listen carefully, okay? Another way to determine if something is a function is by doing what's called the vertical line test, okay? Take your pencil and hold it vertically like this. Okay, so we know this is vertical, right? Okay, so the vertical line test, okay, we know how to determine if it's a function or not if we have ordered pairs, right? We look to see if the x repeats and if it's going to 2 different y values. But what we're about to look at are graphs. And we don't have points on there, right? It's just a nice smooth graph. So we're going to use our pencil as our vertical line, and we're going to hold it across the graph and see if it hits the graph in more than one location. So if you're watching this video, I will do something on the video here in just a minute, and you're just going to have to listen for right now. So those of you that are in here, if we take our pencil and we hold it vertically over number 1, you can see the graph only hits in one location right there. See? It hits right there. This is the graph. It's called a parabola. If we hold it here, it only hits in one location. Doesn't matter where we put it, It's only going to hit in one location. That means every x value, no matter where you put this along the x-axis, it only has one y value. No matter where you put it, it only has one y value. Okay? So here's how you can draw it in your notes. If you take your pencil, pretend this is your pencil, and you hold your pencil right there. It's only hitting the graph in one location.
Oh, okay.
Hold your pencil right here. It's only hitting in one location. Hold your pencil over here. It's only hitting in one location. Okay? That is a vertical line test. As long as it only crosses the graph one time, you're good. It's a function. Okay? So is that parabola a function? Yes. Look at number 2. Now I could put my pencil right there and it only hits in one spot. So can I go ahead and write that that is a function?
No.
Because if I put my pencil over here, now it hits the graph in 2 locations. So
So it's a little swirly line, that's the spot that you're trying to hit.
you want to find anywhere on the graph where if you hold your pencil vertically, if the graph hits it 2 times, the pencil, then it's not a function. So this one would not be a function.
So the little squiggly line matters, not really the little.
Oh, you're not looking at the x-y axis. No, right. You're not looking at the x and y axis. You're only looking at the, when I say the graph, I don't mean the coordinate plane. I mean the graph of the function. So this is a parabola. We're looking at that. This graph does this weird thing. This graph right here it's called a linear. It's a line. It's linear. So hold your pencil over that, and you'll see that it only hits in one location each time. It only hits in one location. So as long as it only hits in one location, then it would be considered a function. Hi!
Hey, you know what? I am so glad we were able to come in here and share this with you and bring some of your assistant principals that know you and see how well you've been learning here at Bach Academy. No pressure, no pressure.
You're on my YouTube video right now that we're creating. Say hi!
Oh, hey. So you're supposed to tell somebody that. There's some patents on my board.
Just we've had kids that have been out for PSAT and stuff, so I pick a different class period each day to record the lesson and upload it to the channel, so if they need to watch it again.
Yeah. And see, that's one of the things one of the practices we do here, when a teacher will actually put a lesson that may be a little bit complex,
This one definitely is.
okay? And so they'll be able to go back, go home, and actually view it again, and go through it again on their own, okay? It's almost like a hybrid flip. You know?
Like Khan Academy, except for it's
It's
Academy.
definitely
Wilson Academy.
Wilson Academy.
Wilson Academy, I love it.
Well, good. Well, we don't want to stop you. Go ahead and use. Went to Miss Greshel's and she said she's not using her Promethean board either, and that she just uses the Apple TV. Do you do that too?
Oh yes, and normally I'm not tethered to this, but when I make my video, whichever class I'm doing that, I have to be. Normally I'm walking around with my iPad. Yes, but it is coming through the Apple TV at the
Oh, okay,
moment.
good. That's great. So the Promethean board you're not using.
No, it's just a projector. Do you want me to keep going?
No.
I don't want to be rude.
Fine,
Okay.
fine. I'm just giving you a hard time.
You wanna
Am
be
I
used
supposed to
that.
say yes? I'm using my Promethean. I don't know what's the right answer, Mr.
I'm
Bush.
teasing you. It's not right. I'm teasing you.
Just be honest.
I am teasing you.
Okay. You got me all sidetracked now. Okay. All right. So after we look at graphs and we determine if they're domain, if they are a function or not, then we also are going to look at a chart. So when you look at the chart here, you see your domain, your x values are 1, 6, and 9. So remember when we had ordered pairs, how the 1 in this case is going to a y value of -3. And if it helps, you can write it as an ordered pair like this. If you want to write them all out, you can write them out all out. The next one is a 6 that's going to -2. And maybe just for our notes, it would be a good idea for you to write that down so that you see how it relates to the ordered pairs and you don't get confused, because this really, all this is a set of ordered pairs, right? Okay? And then we have 9 that goes to 1 and 9 going to 3. Do you see like an alert right there? Like, oh my goodness, uh-oh, ding, 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 ding. What?
Going to -1 and -3.
It's not a function. Thank you, Liam. It is not a function because you can't plug in 9 and get an answer of 1 and, oh, is that a -1?
Yeah.
Oh, I'm sorry. I'm sorry. You can't get a -1 and a 3. Not for. Yes. Okay. All right. So we're going to write no. You know how a minute ago we talked about absolute value, and I said you get two answers there? Okay, but when you get two answers with absolute value equations, we're going to get to an absolute value equation. When you graph it, it makes a V. So when we get later in the lesson to the graph that's a V, remind me to kind of tie in this concept here, okay? And I'll explain the difference there, okay? All right. Man, I got a little off track there for a moment. Did you guys get a little off track there for a moment?
Yeah.
Poor Mr. Moses. He's like, you should have told me. Okay, so, oh yes, this is because I don't stand still very well or sit still very well.
So it's 4?
Yes.
I don't see
It's actually for students that are busy students, but I'm a busy teacher, so helps me with my. I need to move around a lot.
My mom has like an online job and she wanted one of those for her, something like that. But we got, yeah, she wanted one of those. And the way that my brother, I don't even know.
They're pretty cool. They're for fidgety students or teachers, I
I
suppose.
just tap my pencil, but sometimes that gets annoying.
There you go. There you go. Okay, we do need to go on. So look at the next one real quick. Do you think that is a function or that is not a function? And before you just spout it out, really look at that and think. It is a function. Do you know some students say it's not a function because they see in their head, they're like, if there's more than one thing going to something, it's not a function. Well, that's not completely true. That's when there's an x going to two different y values. You can have a bunch of different x's going to the same y value. You just can't have one of these going to two different y values.
Right.
Okay, so that one is a function. Good. All right, this is where it gets kind of intense. So I really need you to focus. Okay, we've got about 10, 12 minutes. We may have to grade homework tomorrow. Okay, because I really want to make sure that I had so many people out this morning because of the PSAT. I want to make sure they have access to this at home. So we're just going to continue, make sure you get a good lesson, and or you can come in during your lunch and grade your homework if you want to do that, or we'll figure it out. Okay, so look at this. Okay, it's called an ellipse. Okay, it looks kind of like a circle, but it's not a perfect circle. It's an ellipse, and we have to. It says find and write the domain and range of the relations using inequalities. Okay. So what I need you to understand is that the domain, and I've got to use this as much as possible so these people that are watching can see. The domain is referring to the x values, right? So it refers to how far, when I say the graph, I'm not talking about the xy axis. I'm talking about this ellipse right here. That's the graph. That's the function. How far does the function go to the left and how far does it go to the right? Because domain means x values, and the x values are going horizontally. So how far out does the graph go this direction, and how far out does the graph go this direction? Well, how far does it go to the left? -8. And how far to the right does it go? +8. You can see that this graph does not extend any further, correct? Okay, so now this is going to be very new. Don't get frustrated. Just write it down. Let's do a few examples, and then if you have questions, I think if you just kind of stick to it, you'll understand. So put a -8 here. Put a +8 over here. We're talking about the x values, so x goes in the middle, and you're going to put less than or equal to signs. What that says is that my domain can be any x value between -8 and 8, and it could be -8, because see, it's on the -8 right there, and it's on the 8, or that's what it's representing, okay? And so that's why you have the equal to bar. On your homework, you're going to have some problems where you just have like an open circle. If you have an open circle, then don't put your equal to bar under there. And it's possible that you could have an open circle here, but a closed circle over here. And if the graph just keeps going like this, it's a closed circle. It's considered a closed circle. Okay? So it's possible you could have an equal to bar here and not one over here. That's possible. Okay, so we've done the domain. Now range means how far up and down are you going to go? Well, how far down does this go? It goes down to -5, and how far up? 5. Now remember, range is the y value. So the range, meaning this graph, can be any y value between -5 and +5. And what do we put in the middle? Y, because it's the y values. Okay? All right, let's look at the next one. Are we good? Everybody have that?
Good.
Okay, look at this next one. Okay, now this, tell me, is that a function?
No.
No, if you do the vertical line test, it wouldn't pass, would it? Okay, it's not a function. But there is a relationship between points there, okay? So the domain, remember the domain refers to the x value. So how far on the x-axis does this graph go? To the left. It goes to here. That's as far left as it goes. On the x-axis is at 0, right? On the x-axis, how far does it go this way?
No.
Infinite.
What do these arrows mean?
Infinite.
It means it's going to extend and it's going to extend. That means it's always going to go further and further that way to infinity, right?
Yes.
Okay, so what that means is this graph can have an x value that is 0 to infinity. So 0 or larger. How do we write that?
I'll figure it out now.
X greater than or equal to 0. What that means is x can be any value that's 0 or greater. Okay? This one isn't going to have x in the middle because we don't have 2 ending points. Okay, this one goes on and on and on and on. Okay, let's do the y now. Look at the y. How far down is this graph going to extend?
Infinite.
It's going to go infinitely negative, right? And it's going to go infinitely, even though, now remember, you're looking up. But as you're looking up, the graph's going this way. So it's continuing to get higher and higher and higher, right? Okay, so that means it's basically going from negative infinity to positive infinity. So that means any y value would be okay. Okay? Now, we're not going to write it. You can put it underneath like this. Well, I don't even think it should have the equal to because you can never actually get to infinity, right? Okay, so you can put that under there, but the way we write this, since y can actually be any number, is you're going to write all real numbers. All real numbers. That means it can be any number. Because if it's going from negative infinity to positive infinity, it can be any number.
That's
How come it's not like that on the
On the x, because on the x it doesn't, on the x-axis it does continue to go this way, but it doesn't continue to go this way. It stops at 0 on the x-axis. There are no points here. When you come this way, you're going back. See, x, these are all positive x values. So all these points are like positive 1, 2, 3. And these down here are still 1, 2, 3, right? It's just the y values that continue to go up and down.
Oh,
Okay, let's look at the next page. Okay, look here. All right, so on this, we're not going to connect the points. What we're going to do is just list them. So to make it easier, let's go ahead and write what the ordered pair is. This one out here is at -4, +1. This one up here is at 0, 2. This one is at 4, 4. This one is at 1, -3. And this one is at 4, -5. So we're going to do like we did in the very beginning. Okay, looking at the x values. What is the smallest x value that you see? -4. What would the next one be? 0, 1, 4. Okay. What about the range? Okay. Go all the way down low. -5, -3, 1, 2, and 4. Right? Okay. All right. The reason we did it that way is because those were just points. It was not a continuous graph. All right, let's look at the next one. I really want to make sure we get through all these, so we're going to have to kind of hurry. Okay, the domain here. Remember, domain is the x-axis. So how far to the left do we have? -5. And then how far to the right? 3. So the domain is going to fall between -5 and 3. The domain is the x value. Those are closed circles at the 3 and the -5. So it's going to be less than or equal to bars. Go to the range. How far down does it go? It comes down to here. Well, pay attention to which coordinate you should be using. -2.1 is how low it goes.
Oh, I see it.
All the way up to 2.8. And that's the y value, and they're closed circles, so less than or equal to.
So it's always going to be the little alligator number is going to be always to the right on these.
It's going to be a less than sign, unless you have one of those where you don't have the two end numbers, like the other one that was just x greater than or equal to 0.
Yes.
Okay.
Oh.
All right, look at this one. The domain. How far do our x values
There you
go? Now remember, here's the graph.
-2.5. -2.
This continues to extend out and up, which means it's still going out. It's still getting more and more negative on the x-axis and more positive on the on the x-axis the other way.
X is greater than negative.
If it's going to continue to negative infinity this way and positive infinity that way, all real numbers. And you can put A, R in if you want. Okay, the range is up and down. How far down does it go? Well, it goes -1.3 and it stops. That's how far down it goes. How far up does it go? Infinity. So it goes from -1.3 all the way to positive infinity. So, how do I write this? Remember, it's my y. My y is going to be greater than or equal to -1.3. Okay, greater than or equal to -1.3. Okay, let's look at this.
Write that the other way also, like -1.3 is less than what?
You could write -1.3 is less than or equal to y. Yes, you could. Okay, look at the next one. The x-axis goes from, how far to the left does it go? Infinity and right infinity, so the domain is all real numbers. What about the range? How far down is it going? Infinity, so that's also all real numbers. Okay, this one right here, x values.
-3.
And only -3, right? It doesn't go anywhere else, so we're going to actually just write x equals -3. Okay, what about the range? How far up and down? All real numbers.
They're all legit numbers.
Okay, last one. This is that absolute value, which I don't have time really to go into more detail, so we'll have to hit on that another time. But the domain, how far to the left and how far to the right is this graph going? As it continues to extend all the way this way and this way, so all real numbers. Okay, and what about the range? How far up does it go?
3.
3, and how far down?
Infinity.
So how do we write that?
X is equal to
No x, no x, no x.
Greater than or less than or greater than
or Y.
Y is less than.
greater than
It can't be less than or greater than.
Less than or equal.
Less than or equal to
infinity.
3. No, not infinity. The highest it goes is 3. Is that the last problem?
Yes.